Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. Multiples are times tables, so the multiples of 2 are the times table of 2. So 2, 4, 6, 8, 10, 12, etc, etc. So the only number in this list that is in the 2 times table is the 6. There are 10 squares in total, so each square is worth 1/10. And if we count all of the shaded squares, we notice that in total there are 7 shaded squares. So that's 7 lots of 1/10 or 7/10. If we put this in a place value grid, and so we've got thousands, hundreds, tens, and units. We've got 9, 0, 8, 8. So it's 9,000, because it's 9 lots of thousands, and 8 tens, so it would be 80. And we've got 8 units, so 8. For us to create the largest number, we need to pick the biggest digits for the start of the number. So the biggest digit is 7, then 6, then 4, then 3. But the question says it wants the largest even number, so we need to just swap the last 2 around to make sure that it is even. So our answer is 7,634. To find the factors of 30, we're just going to write down all the factor pairs, or all the pairs of numbers that multiply together to make 30. So 1 times 30 is 30, 2 times 15, 3 times 10. Now 4 doesn't go because 30 is not in the 4 times table. 5 times 6, and we notice that if we pick 6, it's just going to be 6 times 5, it's just going to be the opposite. So the factors are all the numbers that we've just written down, so it would be 1, 2, 3, 5, 6, 10, 15, and 30. In this question we're given the output as 53, so we know that the output was 53. So now we've kind of got to work backwards. And when we work backwards through a function machine or a number machine, we do the opposite of what it says. So this first one says plus 9, but when we go backwards we do the opposite, which is take away 9. So we do 53 take away 9, which is 44. Now we can check that by going the other way, so 44 plus 9 is 53, so that works. The next one says times 4, so the opposite would be divided by 4. So we're going to do 44 divided by 4, and that gives us an input of 11. Now let's check the whole thing. We put in 11. 11 times 4 is 44. 44 plus 9 is 53, so we know we've got it correct. So for this question we need to convert the percentage to a decimal. So to do that we get that 8.9%, and we just divide by 100. And so that will give us 0.089. And so we get that 0.089. Of normally means times in maths, so we just go times that by 457, and that will give us 40.67. If we write in how many sides each shape has, triangle has 3, quadrilateral 4, pentagon 5, hexagon 6, you'll notice the number of vertices is twice the amount of each of them. So if a shape has 15 sides, we just times that by 2 and it will have 30 vertices. In this question we're given 13 lots of x and we're adding 7 lots of x to it. So if we have 13 lots of x and we're adding 7 lots of x, we're going to have 20 lots of x, or 20x. So 55% is the same as 55 over 100. And what I can do is I can divide top one of the fraction by 5. And so that is going to equal 11 over 20. Now in total there are 20 squares here because there's 5 across and 4 down. 5 times 4 is 20. And if there's 20 squares and we're looking to shade in 11 20ths, it's just going to be 11 squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We're going to start off with a dot at minus 13. And it says that x can be greater than minus 13. And greater is to the right of that. And it goes on forever, so we just put a little arrow saying it goes on forever. Last thing we do is check to see whether it's hollow or a filled in dot. Well, this cannot be equal to minus 13, so it remains a hollow dot. So what we do is we notice that to get this 10, we add the 3 and the 7. To get this 17, we add the 7 and the 10. And to get this 27, we add the 10 and the 17. Whenever we have this kind of sequence, it's called a Fibonacci sequence. You essentially add the previous two terms to get to the next term. And so what we need to do is just simply add the 17 and the 27. When you do that, you get 44. So our next term is 44. The first piece of information I'm going to focus on is the fact Denver gets 8/19. Denver gets 8/19. That means that Engel and Fido together must get 11/19 because they have to add up to 1. So we're only looking at 11/19. I'm going to focus on the ratio next of Engel to Fido. So it's 9 to 5. And let's have a look and see, well, first of all, how many parts there are all together. So 9 plus 5, which is 14 parts. So there are 14 parts in total, and the share that they get is 11 over 19. So what I'm going to do is find out what fraction one of those parts is worth by dividing 11 over 19 by 14. So each part is worth, and I'm just going to keep this into my calculator, 0.041 blah blah blah. And we're asked to find Fido's share. Well, Fido has 5 parts. So Fido has 5 parts, each of them worth 0.041 blah blah blah. I've kept it in my calculator to keep the accuracy. And when I do that, I get 0.206 blah blah blah. Now we're asked to work it out as a percent, so I'm just going to times that by 100. So we have 20.676 blah 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 percent, and it wants it rounded to the nearest percent, so that would be 20%. Or actually, it would be 21% because this would round it up, so 21%. To answer this question, we need to cut this shape into 2 shapes. So we're going to draw a line across here, and we're going to cut it into a rectangle and a triangle. Now we need to first of all label the parts of the triangle. So the length or the width of the triangle, the base, will be the same as the base at the bottom, so that will be 20 centimeters. And we need to find the height, which is this length here, which is 90 degrees to the base. And to find that, what we can look at is the fact that the total height of the whole thing is 13, and the height of the bit we don't want is 11. So what's left over? Well, 2 centimeters will be left over, so the height will be 2 centimeters of the triangle. So let's work out the area of the triangle first. Which is going to be half times base times height. Half times the base, which is 20, times the height, which is 2, will just give us 20. Now let's work out the area of the rectangle. And that's just going to be the width times the length. Width is 20, the length is 11, so that would be 220. Then to work out the total area of the whole thing, we're just going to add those together. So 220 plus 20, which is 240. The units are all in centimetres, and so the area units will be centimetres squared. So with a stem leaf diagram, the numbers in the middle often represent tens. They could be units. So we look at the key first of all, and we see that 3 line 9 means 93. So the numbers in the middle are going to represent 10. So this is a 90. Now we're looking for English, so this will be 92. So our first number will be 92. Then this will be 10 tens and a 4. So it would be 104. 11 tens and 1. So 111, and then 11 tens and 2. So to find the median, we go cross out the biggest and smallest until we're left with 1 or 2 in the middle. Here we're left with 2. So what we're going to do is we're just going to add the 104 to the 111, and we're just going to divide that by 2. So when we do that, we get 107.5 or 0.5. So our answer is 107.5. So to draw this straight line graph, what we're going to do is just pick 3 x coordinates, which is -2, 0 and 2. So I'm going to start off with -2, and I'm just going to substitute it into the equation we've got here. So y equals -2 times -2, because that's what we're putting in, plus 8. -2 times -2 is positive 4. So it's going to be 4 plus 8, which is going to be 12. So at -2, our graph is at 12, which will be here. Then we're going to put in x equals 0. So it's going to be y equals -2 times 0 plus 8. Anything times 0 is just 0, so it's just going to be 0 plus 8, or just 8. So it's going to be 0, 8 will be our next coordinate. And then finally we've got x equals 2. So it's going to be y equals -2 times 2 plus 8. -2 times 2 is going to be -4. And -4 plus 8, which is the same as 8 take away 4, so that's going to be 4. So at 2 it's going to be 4. So we get our ruler to be able to draw this in. We try our best to make sure it's as neat as we can, and make sure it continues on for the whole graph, so no gaps. So trying to describe the single transformation, it kind of looks like it could be a rotation, and it would be a rotation of 180 degrees. But if it was a rotation, it would be actually this way around. And so it's not a rotation. It looks to me like it's a reflection, which it is. Now we've got to find out where we put our mirror line. And our mirror line for this would be a horizontal line. So if I just guess and I put it down here, notice that B is only 1 jump away from that, and yet A is 1, 2, 3 jumps away from that. So that's not very good. That's not the halfway point. So we need this to be the halfway between the two shapes, which is going to be here. And the name of that line, well, everywhere along that line, y is equal to -1. So we call it the y equals -1 line. So it's going to be a reflection across line y equals -1. A sample space diagram is basically a diagram that shows all the outcomes, and we've got the outcomes from spinner 2 at the top, so either 1, 2 or 3, and we've got the outcomes from spinner 1 down the side, so A, B, C, D or E. And we're just writing down all the combinations. So this will be A2, A3, and then this will be B1, C1, D1, E1, and this will be B2, C2, D2, E2, and this will be B3, C3, D3, and E3. And this represents all the possible outcomes you can get from both spinors. To work out the circumference, we need the diameter, and the diameter is just the full distance across a circle. So to work out what the diameter is, we're just going to get that radius and times it by 2, which will give us 30 centimeters. The formula for the circumference is just pi times the diameter, and that's going to be pi times 30. And when you do that on the calculator, you get 94.247 blah blah blah. And when you round that, you will get 94.25. We rounded to 2 decimal places because that's what the question asked us to. So here we have a back-to-back stem leaf diagram, and we're going to focus on just the girls first, because the right-hand one is normally easier to do. So the stem here gives us all of the tens by the looks of it, and then we put the units in here. So we've got 102 here and 105 here, so we're going to put a 2 here and a 5 here to represent 102 and 105. Now they go from biggest being the right hand side and the smallest being nearest the middle. We've got a 90, 92, so 90 and a 92, and we've got a 73 there. And the key we can have for the girls is just 7 line 3 is 73 hours. It doesn't actually matter which value we pick. We could actually pick a value that's not on there, so 6 line 3 equals 63 hours. It's just a way of showing that that 7 represents a 10 and not a unit or anything else. Okay, so we're going to do the boys next. I'm going to pick a different colour. Now the boys gets tricky because it's actually the smaller numbers go in the middle. So when we look at 72 and 76, the order will be actually the 2 first and then the 6. Then we've got 80 and 81. So it'd be 80, then 81, and then we've got 93 there, so the 3 will go there. And the key's a bit weird as well, so if we look at this part here, it's 2 line 7 there, so let's copy that down, so 2 line 7, but that actually represents 72, so it's kind of the other way around. So the left-hand side of a stem leaf diagram can be a little bit confusing. Just remember that the smaller numbers go in the middle and the biggest on the outside. So on the left hand side, the biggest will be on the left hand side. So we can see that the first 4 of these have already been plotted. Now it's really important that you you do the coordinate the right way around. So the first one is number and then algebra. So we're looking at this coordinate here. We're 18 on number, which would be here, and then 14 on algebra, which would be this point here. 12 on both, so 12 and 12 would be here, and then 21 and 17, so 21 and 17 would be roughly there. A plan is a view that you would get if you were on top of the shape, so you were in an airplane or something looking down on the shape. So the sides of this that we'll see, well, we'd see this bit here, and we would see this bit here. So I'm going to start off with the first bit I shaded, and we've got to figure out what the different lengths will be. Well, this would be 2 centimeters across, and the whole thing is 8 centimeters. The bit we don't want is 3 centimeters, so this part here will be 5. It would look like it was 5 wide. So let's draw that on, and so we've got 2 centimeters down, and we've got 5 across. 1, 2, 3, 4, 5. And this is what it would look like from above. Now the other part will be same 2 centimeters, but it will be 3 centimeters across. So we have 3 centimeters across. Now whenever you have a join or a change in elevation, you need to show that with a line across, and so this will be our completed answer. The experimental probability is the successful outcomes divided by the total number of outcomes. So we're looking for the probability that it's white, so it's going to be 25 over, and we're just going to do 35 plus 25 plus 31, which is 91, and that's our probability, 25 over 91. Be careful when it say total, you must include all of the outcomes, so red, white, and other. To find the area of a parallelogram, we use a simple formula, which is the area is the base times the height. Now the base and the height must hit each other at 90 degrees. So this length here is not counted as the height because it doesn't hit the base, which is here, at 90 degrees. The height is this length here, and the base is either this length here or the length at the top. It doesn't matter because they both hit the height at 90 degrees. So we're going to do the base, which is 11, times the height, which is 3, and that gives us 33. Now both of the base and the height are in centimetres, therefore the area will be centimetres squared, 33 centimetres squared. So when you look at this graph, it looks like it's going down as well as up. So it goes down to start off with, and then it starts going up, but then it starts going down again. And when you're looking at trends, you're looking, generally speaking, what's happening with it. So if you kind of draw a line to represent roughly where the graph is going, that line is going to go up. So the general view on it, the general trend, is that it is increasing. So you can write general increase in emissions. So I'm going to start just by writing out the equation, and I can put my lines in. Okay, we're asked to make x the subject, so we're going to first of all add 10 to both sides. In fact, I'm just going to move all this over a little bit so I've got a bit more space. Okay, so we're left with m plus 10 on the left hand side, and we've got 1/7 x on the right hand side. Now to get rid of the 1/7, what I can do is just times both sides by 7. So 7 brackets m plus 10 equals x. So x therefore would equal 7 brackets m plus 10, but it says expand your answer fully, so we're just going to expand the brackets, 7m plus 70. So we're looking for angle DEC, which is this one here, but we can't go directly there. We've got to kind of work our way towards it. And the first thing I'm going to look at is these set of parallel lines here. And we've got a line going through these parallel lines, which is this line. If I try and do it without removing it, this line here. And so therefore this angle here and this angle are going to be corresponding. So this is going to be 69 degrees. So I need to write that down properly. So angle CDE equals 69 degrees because of corresponding angles. Okay. So if I know that the CDE is 69, I also will know that this angle here is 69 because they're the bottom two angles in a triangle. Now, when I say that, I mean when an isosceles triangle is the right way up, the bottom two angles are equal. So they're the bottom two angles in an isosceles, although the isosceles is on its side here. And we need to write that down, so it would be angle DCE equals 69 degrees, and this time it's because it's an isosceles triangle. And finally, we can work out what CED is by taking those away from 180. So angle CED, or actually I should keep it as it says in the question, DEC, is equal to 180, take away the 69 plus 69, And the reason for that is angles in a triangle equal 180 degrees. And when you do that, you get the answer of 42 degrees. So the answer is 42 degrees. To find out what the value of x is, we first of all have to find out what the value of y is. And we can notice that we've got two sets of parallel lines here, and a line going through them. And we kind of got these f angles, which we have to call corresponding angles. So we know that 2y minus 50 is equal to 78. And we must write down the reason, so corresponding angles. And corresponding angles are equal. Now here we've got an equation and we want to solve it, so we get our lines in. We'll go first of all, add 50 to both sides. So we've got 2y equals 78 plus 50, which would be 128. And then we're going to halve both sides, or divide by 2. So we've got 64. So we know that y is 64. And so we look back at the diagram to find out how we'd work out x. Well, what we can do, there's a few different things we can do. We could work out the fact that these two here are vertically opposite. That would be absolutely fine. But actually, if we look at this part here and this part here, these are also two parallel lines, and we've got this angle here and this angle are going to be alternate. So I can write that down here. So angle ECB is equal to 78 degrees. So this will be 78 degrees. And the reason for that is alternate angles. And then finally, if we know this is 78 and we know that this is 64, because we know what y is, then we can work out what x is. So x equals 180, angles in a triangle, take away the 78 we know and the 64 we know. And the reason for that is angles in a triangle add up to 180 degrees. And just make sure you write down all the reasons as you go. And when we take away the 78 and the 64 from 180, you get 38. So x is therefore 38 degrees. A frequency polygon is like a line graph. In fact, it's a type of line graph. But it is when you have the data in a group. So we've got the data here as a group of 0 to 80. So there are 11 at 0 to 80. And then 18 at 80 to 160, and 6 at 160 to 240. Now, where am I going to plot this? It will involve putting a cross somewhere on this graph. And it would seem unfair if I put it all at 0, and it would also seem unfair if I put it all at 80. So what we do is we find the midpoint, the halfway point between 0 and 80, which is obviously 40, and we plot our coordinate there. So seems to be going up in 2s, so it would be there. So that's at 40, 11, the coordinate. Our next one, we plot at the midpoint again, which would be 120, and it's just halfway between 80 and 160, and it's 18 high, so it would be up here. And then the final one is at 200, and it will be 6 high, so 200 is halfway, and we're looking at 6 high, so it would be here. Then when you're done, you need to join them up with straight lines. So I'm just going to get my ruler, join them up, perfectly straight lines, and there we are. So for us to work out the average speed, so we've got to first of all remember the triangle. So average speed is total distance over total time. And we're told to find the average speed before stopping. So stopping is shown with a horizontal line on a distance time graph, so it's up to this point here. So the average speed will be the total distance, which would be 20, over the total time. So 9:30 to 10 will be 30 minutes, but since our unit will be kilometers per hour, we need that in hours, which will be a half. and 20 divided by a half is going to be 40. So our answer is going to be 40 kilometers per hour. We can't work out what x is straight away, but we can find this value here. And we know with Pythagoras we can find a third length if we've got other two in a right angle triangle. So a squared plus b squared equals c squared. And a and b were labelled. C is always opposite the right angle, so it'd be 49 squared plus b squared equals 68 squared. And 49 squared is 2,401. And 68 squared is 4,624. So we are solving here, so let's get our lines down. And we're going to start by subtracting the 2,401 from both sides. So we've got b squared equals 2,223. Then we're going to square root both sides, and we've got b equal to 47.148, blah blah blah. Okay, we're now looking at the second diagram, and this time we're going to have a, we've got our b, and we're going to call x the c. So it would be a squared plus b squared equals c squared, but this time a is 39. B we are given as 47.148, we've just worked that out. And we're looking for c, in fact we can call it x now. Okay, so we need to square that. So we do 39 squared plus 47.148 squared, and that will be 3,744 equal to x squared, and we'll just get our lines in because we need to square root both sides, and we get 61.188 blah 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 is equal to x. It says it wants it to two decimal places, so that will be 61.19. So we know that James knows that he has a square, so we can actually get rid of all of this bit. It's not relevant at all to the question. And the question asks, what is the probability that the square is blue? Well, there are 3 blue squares, so it will be 3 over, and how many are there in total? Well, it says the total is 17. So the answer is 3 over 17. So factorise means to put it into a bracket. And it looks like it's a quadratic here, but it's actually just a linear factorising because we don't have a number term. So we're going to just use one bracket for this. And looking at these terms, I'm going to focus first on the numbers. So 20 and 30, I can divide both of those by 10, and that will leave 2 and 3. So that's the numbers done. Next, I'm looking at the t terms. So we've got t squared there and a t there. So we can divide out a t, but that will leave a t on the first term. And finally, I'm going to look at the u. And there's just a u on both of them I can factorise out. And actually, that just leaves nothing on the inside of the bracket. Now, always when you do this, expand the bracket to check if you've made any mistakes. So I'm going to do smiles and rainbows. There's loads of different methods. So 10 times 2 is 20, t times t is t squared, and then the u, plus 10 times 3 is 30, times t times u. So we know we've got the right answer. So our answer is 10tu brackets 2t plus 3. Something we know about rectangles is opposite sides are equal. So these two will be equal. And these two will be equal. And you notice now that we've got simultaneous equations. So what I'm going to do is get the coefficient of the y the same. And I'm going to do that by multiplying everything in the second equation by 3. So we get 6x plus 9y equals 123. And I'm just going to write in the first equation underneath, because with simultaneous equations we work downwards. Now looking at the signs, they are the same, And the S in same is the S in subtract. So we're going to subtract going downwards. We're just going to subtract going downwards. So 6x take away 3x is 3x. 9y take away 9y is nothing, which is good. That's what we need. And then 123 take away 93 is 30. We're going to get our solving lines in, and we're just going to divide by 3 both sides. So we've got x equals 10. So we know what x is, but we need to find out what y is. So what I'm going to do is I'm just going to pick one of the equations. I could pick the 2x plus 3y equals 41 and just substitute the value of x in. So 2 times, instead of x, it's times 10 plus 3y equals 41. So it would be 20 plus 3y equals 41. Get my solving lines in. And we're going to take away 20 both sides. So we've got 3y equals 21. And then we're going to divide by 3 both sides if I don't run out of room. So y equals 7. So we've got x equals 10, y equals 7. Now I could check that with the first equation as well. So 3 times 10 is 30, 9 times 7 is 63, 30 plus 63 is 93. So we know we've got it right. When it's said that y is inversely proportional to x, it means that y changes as 1 over x changes. And to write this in an equation, all we do is we just write y equals k over x. Now k is something we need to find. So what we need to do is find out what a value of y and a value of x are somewhere on the graph that would be formed from this, and we've got that in this question. So we know that when y is 7, then x is going to be 7.9. And what I need to do now is just draw my lines down. And what I'm going to do is I'm going to just times both sides by 7.9. And so we have k equals, and it'd be 7 times 7.9, which is 55.3. So we know that k is 55.3. So I'm just going to rewrite this equation here, or this formula here. But instead of k, I know that it's going to be 55.3. So our answer is y equals 55.3 over x. The surface area of a sphere is found with the formula 4 pi r squared, with r being the radius of the sphere. So we're going to do 4 times pi times the 20, and that gives us 5,026.548 blah blah blah. And when we round that to 2 decimal places, we get 5,026.55 centimeters squared. So we're going to first of all look at the starting section. So we've got the probability of a blue being picked from bag 1 is 7 over 11. So the probability for blue and red must equal 1. So what do we add to 7 to get to 11? Well, we add 4, and so it would be 4 over 11. So these two here must add up to 11 over 11, which is 1. Looking at the next section, we've got 11 over 15 chance of picking a blue. So what's the probability of picking a red? Again, 11 over 15 plus the probability of a red must equal 1. So that's going to be 4 over 15. 4 over 15 plus 11 over 15 is 1. And we've got the final section down here. Now, this final section, we haven't got any fractions for, but bag 2 is independent of bag 1. So bag 2 is just sitting there ready to be picked after we pick bag 1. So the probability is going to be exactly the same as the ones at the top. I'm going to draw out the two triangles that we have here just separately, and so we can see a little bit clearer about what's going on. And it's actually good advice to actually draw them separately. And so here we've got AB, which is, if I get off that mode, 33 meters. And so this is AB. And this other triangle is ADE. Should probably have labelled that on. And we've got the 91 there, and we've got 13 there, and then we've got 147 here. I think that's all. And we're asked to find length AD. So the first thing to notice is that these triangles are similar. And the way we know is that this angle and this angle will be equal, because on the original diagram you can see that they make an F, which means they're corresponding because we've got the parallel sides. Same with these two angles, they're going to be corresponding for the same reason. And this top one is a shared angle, so they're going to be equal on both diagrams. When you've got two triangles that have equal angles, they're definitely similar, so one's an enlargement of the other. If they're similar, it means that we can find a scale factor. And so what I'm going to do is just find a scale factor between the 13 and the 91. To do that, we do the big number divided by the little number, and that gives us 7. So the scale factor is going to be 7. And we're going to work backwards with the scale factor, and we're looking for length AD, which is this length here. And so we're going to do this one, and we're going to times it by the scale factor. So times it by 7 to find out what the new length is. So 33 times 7 is 231. So I'm just going to write this question out just a bit bigger so we can see it a bit better. Okay, so we've got numbers and we've got letters. Let's focus on the numbers first. We've got 77 over 11. So 77 divided by 11 is just 7. So the answer will just be 7 with the numbers. And here we've got x to the power of 11 divided by x to the power of 6. When you divide powers of the same base, and they're both x, you take them away. So you do 11 take away 6, which is 5. So we notice with these simultaneous equations that the coefficients of the x's are different and the coefficients of the y's are different. But if you look at the coefficients of the y's, they are similar. If we multiply the 4 there by 3, we will get to the 12 there, and we ignore signs. I know it's a minus 12. So what we want to do is multiply everything in that equation by 3. So it's going to be 2x plus 4y equals 20. And we're just going to put our lines in, because what we want to do is multiply everything here by 3. And so we get 6x plus the 12y equals 60. And I'm just going to write that out again, so we can put in our simultaneous equation circles. And I'm just going to write the second equation again underneath, because simultaneous equations are all about working downwards. So I'm just going to show that with these circles here. Now for the coefficients that are the same, which is y, we're going to look at the signs. Are the signs the same or different? Well, if they're the same, we're going to subtract. If they are different, we're going to add. So d in different is the d in add, the s in same is the s in subtract. Well, they are different, one's a plus, one's a minus, so we are going to add. And we're going to find the sum of these. So 6x plus 3x is 9x. 12y plus minus, which is just a minus, so it's 12y minus 12y is 0, which was the whole point of adding, to get rid of those y's. And then 60 plus minus, which just means minus 42, which is going to be 18. Then we just go quickly solve that by dividing both sides by 9. And we get x equal to 3, or 2 even. So x is equal to 2. Now we need to find out what y is. So what I'm going to do is I'm just going to copy out the first equation, but I'm going to substitute in the value of x, which is 2. So we've got 2 times 2 plus 4y equals 20. Again, put my solving lines in, because the first thing I'm going to do is take away the 2 times 2, or take away the 4 from both sides. So we've got 4y equals 16, and then we're just going to divide by 4 both sides. So we get y equals 4. And we can check that with the second equation by substituting in the values of x and y. So 3 times 2 minus 12 times 4 is equal to minus 42. So the first thing I notice is the second equation isn't really in the normal format for doing simultaneous equations. So I'm just going to rearrange it so that we have it where we want it to be. And I'm just going to put my lines in so I can rearrange. So the first thing I want is I want the x's and y's on the same side. In fact, actually all I need to do is take away 4y from both sides, and we get 5x minus 4y equals minus 7. Okay, so what we do now is we put both our equations down so we can solve these simultaneously. So 5x minus 4y equals minus 7. And you notice the coefficient of the y is already the same, so we don't need to multiply anything. But the signs are different, and the d in different is the d in add. So we're going to add going downwards. So we're going to add everything. So we're doing 3x plus 5x, which is 8x. 4y plus minus 4y is nothing, which is good, because we want to get rid of that. And 47 take away 7 is 40. All right, let's put our solving lines in. And we're going to divide by 8 both sides. So we get x equals 5. And we're going to substitute that value into one of the equations. I'm going to pick this top one. So instead of 3x, we're doing 3 times 5 plus 4y equals 47. Get my solving lines in. So that will be 15 plus 4y equals 47. And then we're going to take away the 15 both sides. And so it's 4y equals 47 take away 15, which is 32. Divide by 4 both sides, and we get y equals 8. Now we can check that using this equation here. So 5 times 5 is 25. Take away 4 times 8, which is 32, is minus 7. So we know we've got it right. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.